So, okay, now that we're kind of getting started here, let's talk a little bit about like, first of all, why am I so late? Why didn't I planned on doing this stream on Saturday? I wanted to stream on Saturday, but my server went down. I have a server that is like a dedicated server that kind of holds all of my infrastructure. It holds everything I do. I originally got it about 10 years ago. Like I started getting a dedicated server for Soundboxing, which was my VR game that I launched back in 2016. And at the time, I was doing some sort of like, I actually had a pretty intensive database setup where, like, I don't know if I want to get into it, but like I needed to do a lot of data. Like there was a lot of scanning that was going on in the database, and I needed a relatively beefy machine. And I found that like I could put my database on there, and then like the actual web server part didn't really do that much. It didn't need a whole lot of the actual web server part could just live alongside the database, and the database was crunching, but the web server was fine. And so I got a dedicated server and installed this thing called micro Kubernetes. Actually, let me grab. So yeah, I installed this on my dedicated server, and then it was really nice. This was great because this is actually a full Kubernetes installation. It's a full one. It's not like there's like K3s, oops, which is kind of like a smaller, slimmer version of it. That's like a re-implementation of Kubernetes. It matches the same APIs and things like that, and that was popular at the time. And there are a couple of these that have gotten popular. But what's nice about MicroK8s is it's the full Kubernetes. It's like real Kubernetes from upstream, and then the only thing they do is they like basically sysadmin it for you. Like they do a lot of stuff to just connect it all together, and they've got like relatively opinionated ideas around like which add-ons are good, which Kubernetes sort of like operators and things are good to use. And then it also has a bunch of setup stuff for around like all the networking stuff that like Kubernetes is all networking, right? But for example, like setting up an overlay network and all that kind of stuff, and a service mesh, and then Ingress controllers. Like if you're into Kubernetes, I actually think this is a pretty good solution, just in general. But my server crashed. Like my server crashed badly. And well, so what's nice about this setup is that like whenever I have a project idea, all I have to do is just throw a couple of like YAML files in there. And I know people aren't crazy about Kubernetes YAML files, but at this point, like I kind of had it down to a science where I have a new project. I put a little Kubernetes directory in there. I put a couple of these YAML files in there. I apply it into my Kubernetes server, and boom, I have like a website on the internet, and it's in my cluster, which is just a single dedicated server. And so that's been nice. It's been super nice that I can just like toss things up there, and it's all standardized. It's all, you know, like since I have for 10 years now used the same setup, everything fits into the same sort of like Lego block packages of the way that I like to use things and the way that things work. And so whenever I've needed to like migrate my server from one to the other, everything is conforming to this like exact it's like everything fits, and so it's really easy to transfer from one to the other, which is pretty nice. And then especially with agents makes it even easier, because you just say, hey, like this is my old Kubernetes cluster, this is my new one, go. But what happened this time, but I don't use all the features of Kubernetes by any means. Like I don't use many of the features. There's like all of these things around like what is it called, row-based access control, and there's lots of different like security features. And then there's also there's all these like higher level things you can build on top. You can use Helm or all of these higher level things that sort of take templated Kubernetes things and bake them out into instantiated Kubernetes things, and there's all these different CLIs for doing that. I don't use any of that, and I just use a very basic Ingress controller. So it's kept things very easy for me, and it's kept things good. But what happened is my server totally died. totally and completely died. And I've been working back and forth with my service provider to figure out what actually happened. At first they were like, "Oh, it's spikes in the CPU, so we swapped out your CPU. You're good to go." And then it didn't work. And then they were like, "Oh yeah, we realized that actually it's a motherboard problem, so we swapped that out." And it still didn't work. And then now they're trying to say, "Oh, maybe you got hacked." And it's been 4 days now. So that was Saturday, Sunday, well, 3 days. In fact, I think it was Friday that I first noticed it, so it was 4 days. And the first day or so took a really long time for them to get back to me. And while I was waiting for them to just respond about the very first time when I first noticed issues, I started looking for alternatives. I started looking for other places to go because I was sitting there just waiting for them there was nothing I could do. And it was completely just like up to them to go, I don't know, turn on and turn off the server, whatever I thought they were going to do. But since that didn't work, I was looking elsewhere, and I did some research, and I found this other place that had relatively good prices on dedicated servers, and I started setting up. And this time I wanted to do, instead of just having a single dedicated server, I'd get 3, and then I have a cluster, and if one goes down, the other 2 can fill in until I can get there and like fix it. And it's not just like a catastrophic mistake and a catastrophic failure, right? So I grabbed 3 servers at this new place, and it was an unmitigated disaster. First of all, the 2 servers came online, and the third one didn't. It just never booted up. And then I started doing just basic care when I connected to these servers and say, okay, what do the hard drives look like? What does their what does their smart readings say? And all of the hard drives were like way beyond their specs. There were dead sectors on the SSDs. Like these were bad. This was a bad situation. And so I messaged this new place and said, "Hey, I need you to swap out these hard drives. Unfortunately, they look busted, and I'm just switching from a downtime from like a catastrophic situation. So I need these hard drives to be valid before I start installing things and start building up my new cluster." And they got back to me and they're like, "Okay, fine, we'll swap it out." And so they said, "Okay, we swapped it out. We've got new hard drives ready to go." And I searched those, and it was literally worse. Like, first of all, actually, once they swapped it out, the server wouldn't boot anymore. And so I had to message them saying, like, now it's not booting. Even when I, use the control panel, it's still not booting. So after some back and forth, they did get it to boot, and then I SSH'd in and I scanned that hard drive, and it was literally worse. It was a worse hard drive in worse shape. And so I messaged them again, and I'm like, "Can we swap this out? Like, this isn't working." It's why it probably wouldn't boot, is probably because there were read errors. And so they said, "Oh yeah, we can swap it out, but we can't guarantee that it's going to be any better than the existing ones that you've had." And so, yeah, like I basically said, "I need a refund, please. Like I can't use this. Like I can't I was just coming out of a situation of disaster, and I'm trying to go to a new platform. I'm trying to like spin up new servers that I can trust." And so that did not work at all. And they ended, to their credit, to this new company's credit, they refunded me. And they were very nice about it. It took them a little bit of time, but they were nice about it. And they were just like, and I was nice to them too. And I was like, "Look, I understand you're like a value oriented service, and you can't be like putting new hard drives in every machine, all that stuff, right?" But so all of that happened. This whole new arc of this new server infrastructure, while I'm waiting for a response from my existing infrastructure, which I've never had a problem with. They've always been great. And so then long story short, I did find a new place. Wait, I don't know if I can say what it is. I'm not going to say all these server things yet because I don't want to endorse them yet. I don't know if it's going to be good yet, but what I did get was something that I was able to find a infrastructure provider that allowed me to programmatically create all the servers and then programmatically assign them to different racks and assign them to like a different availability type zones. And also they charged a fee to set it up, but it actually felt like it was done in an incredibly professional way. It all had automated systems. There was no problem. And when I SSH'd into them, they had good infrastructure. None of the drives were failing. Everything and everything worked correctly. Like it did land on different racks. I was able to get private networking working. And then basically now I've got this new sort of setup that I can call it I'm calling it Epsilon. Oops. So, yeah, this is like before when I was talking about setting up this Kubernetes cluster of a single node. I just did that all manually. I went in, I SSH'd in, and like I was just doing it old school cowboy sysadmin way, where I was going through the tutorial at the time and saying like not local Kubernetes, but like I was just following the docs, copying, pasting the different commands. I think it was like using snap or juju or something. I don't even remember. But it was just I was just doing ClickOps and manual stuff. But in the process of moving over to this new triple server situation, I needed to get things more into like a little bit more of a good shape. And so that's what this is. This is like I had this whole like I had agents go and map out all the old stuff, and I still have never recovered the data from my old server. Thankfully, I had at least thought ahead enough to do database backups. So, for example, soundboxing, it's good. I had a database backup. It was like it was like 1 day old or even 6 hours old compared to the latest stuff. And so I was able to just get most of my things back. Anything I really cared about had a database that had stuff saved in backup, and we were good to go. But I was just hoping I could get like the full data set. And there's a few things here and there, especially for some of my side projects, my like agentic side projects that just didn't make it. Like there's this one thing called Folk Reel. I wish I could like go to the website and show you. But it was this like vibe coded idea that I had around, and maybe I'll be able to revive it someday and talk about it more. But it was this like vibe coded idea I had around having an agent that was constantly interviewing you about your projects. And like I had this landing page where you could just pull up and start recording videos of yourself and saying like, hey, I just worked on this, like kind of like a diary of your project. And I was thinking like eventually I was thinking about all these old documentaries that came out like when the internet was first coming out. Like what's that guy's name? Cringely? Yeah. So this like Nerds 2.0.1. I was watching some of these older videos. Here, let's see if I can find one. And it's like so exciting. It was such an exciting time for I don't even know if I can is the audio working on this? Oh yeah.
Are you going to Scarborough Fair? Parsley, sage, rosemary, and the information superhighway of the 70s, the first ever computer network, was a tool built mainly by.
But it was just all these interviews with all these people.
Is the Ethernet cable?
Let's see if I can find a better one.
So we had an.
These are like.
More interestingly,
now is that.
The result of
and so with
this type of stuff,
tears in
where
our
it was
eyes,
like
we took
in
our
the
$5
moment
up to
interviews
this,
with people
Secretary of State's office
as they
in
were
San
developing the
Francisco
internet,
made Cisco Systems and took it anyway.
like their thoughts about the way that things were going to go and where things were going, and like their it just feels like there's so many parallels to today with all this agent stuff. And they had ideas, and they were right about a lot of them, but they were wrong about a bunch of other things, like the information superhighway and all this other stuff. Anyway, so I was thinking about all these different old school documentaries and trying to make a site around it. And unfortunately, the video upload stuff was stored on the server in like a persistent volume claim and not uploaded to some bucket somewhere with B2 or S3 or something like that. So that didn't get saved. And I am still working with that company to try and get service back and see if I can recover anything, but we'll see. Anyway, this was a huge long tangent about nothing, but except the fact that my server died. So I spent that's why I didn't stream on Saturday. I was kind of just like trying to debug and figure out what to, like, I was tracking things down. And on Sunday, I was actually communicating with all these the new service provider and trying to get a new service set up. And then today, and then yesterday, today I worked my day job, but yesterday I was working on getting this new Epsilon service. And why do I call it Epsilon? I think it's kind of a cool name, but really it's just that like I did my first server was alpha and then my second one was beta, and now we're just all the way to Epsilon. And so I just called this project Epsilon. But it's kind of a cool name anyway. But so what am I looking at? What is this right here? This is Neural Column. This has been like this little fun mini project that I've been hacking on stream. And so I think there's some stuff we could do here where there's some things that I like as I was preparing this here today. I found a few things that I'd like to fix. Like, okay, actually that's what this is working on right now. That the history seems truncated. I think I actually figured out what that was. And the problem is it's more fallout from this migration, which is that I actually had two buckets. I had the old bucket, and then I had mirrored it into a new bucket. And in the new bucket, the history is, this is actually like, I think this finished. See, I love agents. I told the agent, what a mess. And what else did I say? Why is my local dev different from what I see in production? The content. I edited some stuff and it's not showing here. There's no more history on my local dev. So anyway, it found out in this last 15-minute chunk that there were two different buckets. There was one that I had been developing on for my dev work and my prod work. It was just kind of like the singleton bucket where all these documents were going into. And then when I did this whole migration process, it created a second backup version, which I was using to while I was testing things out. And then when I transferred over the production to the new system, it pointed the new system at the backup sort of bucket. And the backup bucket didn't have all the previous version history. So this is the process where I went and I flipped it back to talking over to the new bucket and then mirror all the new changes that I've done into the new bucket. And that's it. But I actually think I need to restart and then, so what the tell is that this was, when I opened it, it was saying August 9th, 2026. I'm thinking why? Well, because I was originally planning on this going out yesterday. So anyway. So yeah, neural column. There's stuff. So that history seems truncated. That's done. I just did that on the startup of the stream. Maybe I don't need to do more neural column work. Let's think about this. So it's like there's a few things here, but the main thing is there have been a bunch of new things so the neural column is kind of like an idea to what to work on. But the reason why I want something to work on is because there's all these new harnesses that came out. We've got Prime Agent. That's this new recursive language model type thing. And we'll talk about that. We'll try it. We'll use it. And I've done some experiments with it, and it's very interesting. I'll talk about my impressions in a minute. And then what I haven't tried at all yet, I've used the new, so Meta came out with a new model, 2 new models, and a new harness. And I've been using the 2 new models, but I haven't tried the harness yet. So I want to see how their models work in their own harness. I want to see that. And so that, like, having something to work on, whether it's neural column or, I actually have another idea of what to do for that. But another thing is, so I'm streaming on Twitch right now, right? I realized that I don't know at all how to make Twitch chat show up on screen. So I started looking into it, and they want, like, every place wanted me to sign up for some service or do something that I just didn't want to do. So I created this little project called OpenStreamAlert. And so it was just a little vibe coded project. I think I put in 2 prompts, or 1 prompt and 1 steer, and maybe 1 like deployment thing. And so this is kind of just like a cool thing here. Let me trigger it. I think I can trigger it right now. Some test messages. This is like a little test message thing. Oops. Oops. There we go. Yeah, so a little test message so you can see how it looks. Oh, wait. Here, let's do talking head so you can see. Yeah, maybe I need to like work this out better. But I don't know, it's kind of cool. And if you look here, I'll share what this looks like. That's bad. Oh well. Anyway, I could probably figure out a way to look at OpenStream. Oh wait, I know how to do it. Oh, actually, I'll even do this. And here, oh wow, lovely. What is going on here? That's so weird. Here we go. Image. Got an image. Here we go. So yeah, this is kind of like what the UI looks like, where on the right side, you get to see like a demo of it. And this is how, like, if I pick the glass theme, this is what it will look like. But somebody's trying to post something, but it's like spam. I'm gonna say no to that spam. Yeah, so this is what it looks like when I was clicking test message to make those show up. It was looking like this. I'll show more again. You know what? I'll show the glass version. Okay, glass. And let's do terminal. Bubbles. Terminal. Glass. Minimal. Maybe I like... Ooh, I kind of like the terminal. That one's not so bad. Kind of fits the theme of the stream, too. So I'll stick with that for now. But yeah, so kind of fun working on this little thing for the stream. And we can like go into some of the code and stuff, but I haven't really looked at some of the code. But so there's that. And then I want to kind of talk a little bit about this super story graph thing. There's this project that I did back in like February or March where I created this story graph prototype, and it kind of turned out awesome, but I dropped it for a while, and I've been kind of I was using Prime Agent to revive it and kind of bring it back to life. And I'll talk about that a little bit. I will talk a little bit about Super Story Graph. Project Epsilon is my new GitOps directory thing here. Ooh, which by the way, I want to show something real quick. I have CI now. Oops, HTTPS. That's not good. I have CI now, at least on neural column. I'll port the others later. But that means when I merge to main and I push and I go to the repository, like it doesn't have a bunch of GitHub actions anymore. It just has my own CI that it pushes to, and I can do anything in here that I want. And I don't have to pay GitHub extra money. And if I ever want to move off of GitHub, it's just a trigger. So everything's happening on my cluster now, which I kind of like. It's kind of a cool thing. I'm kind of liking this whole like doing things properly. Oh, also I'm using SOPs. SOPs are amazing. SOPs are freaking incredible. SOPs is this idea where, and I didn't even I have encountered it at work. We're using it at work, But I didn't even say I need to be careful about what I click on, but let's see. I think I can just click on stuff. So let's click on neural column because I don't care that much. But you basically can check in your secrets. You check them in, which is so nice because then you don't have to like git ignore some directories and not others, but they're encrypted so that like you can check them in and anybody can download this file. I'm showing it on stream just fine because although let me just see something. Like I'm actually just going to go to literally if I'm live streaming, am I okay to show on stream? I should be okay, right? Because of the way SOPs works. Let's just see. Let's see what this says. I think so. I think the idea is I don't think that this will compromise. What I'm all of a sudden questioning is whether you can like be by looking at this stuff, can you compromise it? I don't think so. If so, well, it's just neural column. Who cares? Although you could get my OpenAI, you get access to my neural column bucket and delete all of my documents. Please don't do that. The stored file is correctly encrypted. All 9 entries under string data are SOPs values, and the configured rule encrypts the entire string data mapping. I'm checking the remaining visible metadata now. Yes, cryptographically, the checked-in secrets are safe to show. It still exposes secret and provider names, namespaces, GCP projects. Yes, that's fine. I mean, yeah, if you're able to hack GCP itself, I guess I'm screwed. But what I really like is we were using these at work. My agent just suggested this, and it's been incredible because then you don't have to deal with all those gitignore.m files. It's pretty incredible. Innovations in security. Let's go back to this. Where was I? So I've got this Epsilon project now. I purposefully have not watched the Hugging Face Black Hat video because I kind of want to just react to it and let's talk about it. I have heard things, I've read about it. There's a lot of smoke around this fire. So I'm aware of it, but I haven't watched the video yet. So I think it might be fun to just do a react video. And there's a bunch of news. It's crazy. Jeff Dean leaving Google, a Qwen 3.8 coming out soon, a new White House model review framework, more agents doing weird things, unobserved agents or agents run amok. And then a really cool thing, which is that Meta released a 30B parameter open weight model. And let's try it. Let's use it. I've got it running right here on another computer. So yeah, let's try it. I've been trying it a little bit. And then something that came out today is that Anthropic is going to start watermarking their text outputs. So let's talk about that. Also, so I talked about this Muse Glimmer just because that's huge for me. But then there's all these multimedia models that I don't really get so into. Like I don't follow them as much. So I found some showcases and demos and stuff, and it might be cool to look through them and see how they're coming along. It seems like H3 is a pretty good one. I've been seeing good things about this, but FLUX 3 as well. Honestly, I don't know much about these, so I'll be learning as I click through. But yeah, so those are kind of like the things that I was thinking about today. And here's what I'm thinking. I was originally going to do neural column, but I'm kind of like not feeling neural column today because wait, history seems truncated. I got rid of that. Oh, you know what? It's another property of neural column where when I change things and it's published, which I like this. It needs to be republished. But okay. But here's the thing. Here's what I was thinking about instead of neural column is let's go to, I've got this video. So whenever I record one of these live streams, and by the way, I'm thinking this is going to be a short one today because it's already 11:30, 11:23. But yeah, what I'm thinking about doing today is that whenever I record one of these live streams, I like dump the video files in this directory that says blah, 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 like date_stream. And like this is all stuff that an agent came in and created. And I just go in and I put codecs or I put Claude. This one was Claude and the next one was codecs. And I just say like, edit this. This first one, I was literally just like, go and edit this and figure out how to edit it and edit it. And then I did a lot of back and forth. Like, hey, this looks awful. You cut out these important bits, but then you left in these really awkward moments. And then I spent a lot of time telling it like, oh, hey, you keep trying to cut, like jump cut and get rid of my ums and ahs and things like that. But you're cutting into the middle of words and you're cutting out the middle of words. And it makes sense because, you know, these things don't have audio. But what I did here is I said, okay, you actually have, I'm going to give you access to a new model called Inkling by Thinking Machines. And it can do audio. It has audio in. And so then I told my codecs agent to basically use an Inkling sub-agent to editorially check over the cuts and make sure that the cuts work well. But like, I kind of like set my codecs going and I like left the room and I came back and it was like working. It was doing all this stuff, right? And I had pointed it also at the previous thing. And the previous thing, if you look in here, it created all this stuff. It created all these Python files as it was like, as it needed a little tool, it would just build the tool and then do it. And then here, the codecs took it like to another level. Just like scrolling down, I was looking through, it's like, I have no idea what any of this does. It's insane. And all of this was just to automatically take my live stream VOD and turn it into videos, to turn it into YouTube videos. And in the end, I get stuff like this. It's like an open models one, this thing here. And then I get text. These are the chapters. And then I get oh no, this is what I upload. Is like I use this as the title. So it gives me titles, it gives me descriptions. I editorialize and I come in and like I add the neural column published link, for example. But yeah, this was kind of funny because I was using Inkling Small. I was talking about Inkling Small, and then Inkling Small was editing, was doing the audio editorialization. So, but I kind of am not excited about the idea of giving, where are we? I'm kind of not excited about the idea of like putting a new directory here and telling either Claude or Codex, like, go again. Look at these two directories and like do that again, because it's going to do this same thing. And look, also like I told it last time to try and like save information about what you're doing. Like, what are your edit decisions? And it's tried to do that and create an editorial map. And I also told it to like go search and learn about the old project. So this is like the archaeology of the past project. So I don't know, like, I'm not super excited about this idea of after this, doing this again, because it blew through my entire codex budget, like, as you can imagine. And I think I spent like $80 on Inkling inference because Inkling Small was not available yet on. Actually, let's see if Inkling Small. I think it was like Fireworks. Yeah, no, it's still not. So they have, I don't know why they do this. Inkling It's serverless. You can like just, there's a dedicated, you can just do fireworks.ai inference v1 chat completions and pass it this Inkling. And so I was trying like Inkling small, Inkling dash small. Let's just do that. But it doesn't work because they don't have like a serverless deployment. Which is a bummer because this is a smaller model. It'd be easier for them to do. It'd be easy for them to just deploy this. So I guess the problem is that I ended up spending money on this anyway. And if they did this, I would have spent a third. So it kind of makes sense. But here's what I'm thinking is like, I think it might be more interesting to use these projects as a test for these two new harnesses. We've got these two new harnesses, right? We've got Prime Agent and we've got Muse Code. So I think let's do a little project around that. I'm going to say Muse Code, what do I call this? Video platform. And I'm going to do another one called, what was it? Prime Agent Video Platform. And let's like do a little bake off. Let's do a little cook off. Let's take, I'm going to delete some, or get rid of some of these other ones. Let's get rid of that. Oh wait, I've got, yeah, this was if I was going to do some neural column development. I already had it set up and working. But I think let's do more like video editing. What's in here? Perfect. Okay, let's stop this. So, first of all, I'm going to do Prime Agent. And by the way, when you set up Prime Agent, it's like a cool setup process. Like it's pretty cool. It has like a nice animation and it does nice things. Okay. I have played around with Prime Agent a little bit, and first of all, I have a lot of thoughts. I have been very interested in the recursive language model stuff since maybe even before it was officially released as a paper. Like the concept of this like of a recursive model that uses a So, okay, there's a lot of debate about what is an RLM. Let's actually just talk about RLM. Red Letter Media, which is, I actually love that channel. But let's bring up recursive language models. Actually, I should probably let's do this. Actually, I'm going to reload because I don't know after this other thing worked. Okay, so I'm going to say new chat. Let's do Kimmy K3. Given these three articles, or these three URLs, underneath research each one and suggest a link or addition underneath the Prime Agent subheading. And it's this, and it's this. These will be useful context for putting all into perspective. So I'm copying that because I don't know how this will. So anyway, this will be a good test for us to see if neural column works as an agent thing instead of me going and manually putting it all together. But I do kind of want to make it a little smaller so that I can see. I'll research all three URLs in parallel, and hopefully it will put it under the Prime Agent heading. I have the archive paper. Why is this going so slow? That's so weird. Truncated mid results. I wonder what that's all about. But anyway, while that's going, let's just talk about what recursive language models are, because there's the name and what the name implies, and then there's like the implementation of it. And like I say, I think the concept of a recursive language model was totally floating around way before this. Like the idea of taking a request, maybe a complex request, and like having a system that can break down that request and send it back to itself, which then that might also need to be broken down and turned into sub requests. Like, you can imagine how easy it is to just imagine a system like this. But that's not really all that recursive language models, as it's presented, has come to mean. The other thing that it has come to mean is this concept of like a code mode, where the recursion that's happening is happening in such a way where it's all happening in the context of a programming language environment that each subagent has access to. So in like a typical tool call, when an LLM needs to make a tool call, it just outputs, hey, I want to make a tool call, and I want to make it with these arguments, right? Your harness will say, hey, we got a tool call request. Let's send that out and then make that tool call with those arguments and then come back and give it the response, right? That's the standard way of an LLM making a tool call. There's this new concept of code mode, where instead of an LLM making a tool call like that, your LLM will just output code. It'll say, here's a block of Python, run this block of Python. And then it's a matter of what do you give into the context of that Python application. And in this case, with these recursive language models, what they're doing is they're using something like if you've ever used an IPython notebook. If you've ever seen an IPython notebook, let's see if there's like an example. Gallery of interesting IPython notebooks. Let's just do Python for data analysis. Okay, great. Working with reactions. Getting started with gdelt. Jeez. I can't find I just want a IPython notebook example. Here we go, basic example. So if you think about an IPython notebook, what happens is you've got these like back and forths between text, it's like a document, and then these little snippets of code. But what's cool is that once you've executed this snippet of code and you come down lower here, you have access to like the variable, like you're writing complete standalone snippets of code, but it's executing in this environment that sort of like builds up context, and it builds up variables that are accessible lower on. And I think you can when you think about an RLM in the way that it's talked about today. Oh shoot! I realize everything is small, or everything is huge. It needs to be small. It needs to be huge. So, yeah. So this is the way to think about recursive language models as they are kind of today. Oh wait, am I doing the right? Whatever. I don't care. You don't need to see my face that big. So yeah, it's like it executes this, and now TD client, PD, and NP, those are available in the context for future things down below to use. And so imagine if one of these functions that was available for lower things to use was like call subagent. And then that subagent was another one of these things that was an IPython notebook, where each time it was outputting Python, the Python was executing in this like environment that is building up interesting properties. So what you get is it's kind of like code mode. It's also kind of recursive. It's this thing where it's like those two things together, where it's running in this IPython type of environment. And it wouldn't need to be IPython, for example, if there was some sort of equivalent to this with like a JavaScript REPL, where JavaScript gets to the next thing, and then JavaScript executes and exports a bunch of stuff into the environment, and then like another block gets executed and it's another JavaScript. That's totally, I think that would totally count as one of these like RLMs. But so, okay. Let's see here. What is this saying? I don't really feel like I want to go through all of this. Like, I kind of explained the way I felt like I want to explain it. You can get far into it. And then the interesting thing is they actually did some training. I believe they did some training. Well, maybe not. Maybe they were just planning on training. But right now, a lot of these RLMs don't. All of these models are really good at writing little snippets of Python code. They're just so good at that. That's just part of their training data. It's part of what makes them good at everyday agentic coding. Yeah. So I don't really know where I'm going with that. I don't really want to get into all the details of RLMs, but this is Prime Intellect's sort of like take on how can we make a really good RLM. This is their version of an agentic harness that is all an RLM. And the first thing I did when I started this on a project was to have it like explore the project and like learn about it. And at that time I used GPT-5.6 Sol, and immediately I spent, I think, $150 or something. Immediately, almost immediately. It was so quick. I had to stop it. It didn't finish even responding to my task, because what it did was it scanned the list of files in the directory, and then it spawned a new subagent for each file in the directory to learn more about it. And it just turned into a token furnace, an absolute token furnace. So then I switched over to GPT-5.6 Luna. So I've been playing around with a bunch of different models. So what's kind of cool is Muse Spark 1.2 is actually, first of all, is a really good model. And second of all, is a very cheap model if you're willing to go to the contributor branch. And we'll talk a little bit more about Muse Spark later, but I found that it was pretty good. It's a pretty good model and very cheap. It's the cheapest model by far if you're willing to use the contributor version, which gives them data. But I wanted to kind of stick away, but it is rough around the edges, Muse Spark. And when I was trying it with the RLM with Prime Agent, it was kind of going into loops. It wasn't quite there. Like, I can see there's a lot of promise there, but it's not there yet. Whereas when I switched over to the GPTs, when I switched over to Luna, in this case Luna Pro, it absolutely nailed stuff. It was doing a lot better. And since it's Luna, it's cheap enough to actually, it's not a token furnace. So yes, so that's Prime Agent. One thing I will say, and I'm going to kick off a job on it pretty soon. But one thing I will say is you have to be a little bit careful, because I found that it installed something to my my system D, and so when I Control C out of it, it was still running in the background. It still had stuff going. And I think they're doing this because they need to like actually have a daemon that's like managing some of this stuff a little bit better. And also because if you look at these are some of like the example prompts I was using. Like I was saying, first explain like I'm 5, then explain like I'm in high school, then explain like I'm a college grad, then explain like I'm a world expert. And I was just giving it different projects of mine and telling it to like explain things. And you can see I was doing like GitOps stuff. But what's kind of cool is that like it keeps track of all of your different agents that are going, and it creates this like this agent sidebar, and a lot is similar to the way that Claude Code works, and it keeps all the agent. I'll show a little bit more when it's running. But okay, let's actually work on, let me put together a prompt. Let's write a little prompt. Let's say let's do a prompt that says, I have now, is there a, oh, word wrap is on. Okay. I have now done agentic video editing twice. You look at directories. Oops. You look at these directories, you will find at their root MKV file representing the raw recording from OBS. In each case, I had an agent come in and create YouTube-ready content. In the case of this stream, I was only satisfied with the one VOD video, which, let me just like find it. Okay, I was only satisfied with the one VOD video. In the second one, in the case of the 802 stream, I was satisfied with all of them in I was satisfied with all of them in there, and I scheduled one or two per day to release on YouTube. One of the things that made the second one better, the second, just gonna spell it all out, better, was its use of a multimodal model, Inkling, to check whether audio cuts were done properly. One thing I didn't actually need or want was the censoring. So when I was talking about B2, it masked out the screen for privacy. I don't actually need it. But it cut out all of it, found the interesting narratives. It cut together a VOD plus many different clips. It put together image thumbnails by finding images or finding frames of myself in funny poses, cutting out the background using AI tools, cutting out the background and and using generating background imagery, then using, I think, an HTML-based compositing strategy to layer the background with me on, then myself, then some text, and making it look nice. In addition, it put together, wait, making the cuts and then having Inkling analyze the audio, checking for and cut quality. Okay, one thing I didn't need or want was the censoring. So when I was talking about V2, it masked out the screen for privacy. I don't actually need that, but it found the interesting narratives. It cut together a VOD plus many different clips. It put together image thumbnails by finding frames of myself in funny poses, cutting out the background. In addition, it put together nice opening sequences that show the topic, the stakes, and what was this, like, had three, there was like a formula, and I can't remember, but there was a nice dialed in formula for creating those titles. It also found public domain music to place in the background. Finally, it put together the the titles, descriptions, and chapter lists for all the content. Here's the deal. It took tons and tons of scripts, many iterations, and lots, and way too, and far too many tokens to get each one of these pipelines through to completion. So what I'm asking you to do right now is to analyze both DIRs, and particularly the newest one, and put together a single document describing what pipeline we could put together from all these pieces and parts in order to get an extraordinarily high quality output like we got the last time, but in a faster, cheaper, more predictable way by using hindsight and reusing pieces and taking the golden path and all we've learned from doing this for 2 weeks now. Put together a singular document and save it in. Sorry, all of this was just to get me to say, put a singular document and save it in this one, I will say Muse Code Video Platform, and another agent will be working in, and you should avoid that and instead stick to your directory. I want your document that you create after researching all of this, all that I've said to be in, and then let's call it like platform plan.md. An agent following the plan with no context should be able to create this incredible, pristine pipeline that takes the raw footage and outputs YouTube ready clips with high quality, high reliability, low cost, low toil, and does it every time, something like that. Okay, and then I'll say this, I'll just give it some motivation. If we get this right, this will be a cornerstone of my pipeline, and I will appreciate your work on this forever. Thank Godspeed. Okay, something like that's lame, but sometimes it is good to give motivation. It's just that this is kind of a lame motivation. And could potentially grow to an industry with something like that. Okay, so this is V1, and then there's another one. So this was the Muse code. Now I'm going to swap it and say another will be working in so this is prime agent platform plan. So this is actually the prime agent one. So basically what I'm going to do is, and then also I'll do Muse here. So this is the prime agent one. I'll paste it. And this is the Muse one. And I'll paste it. And it's not quite, actually, before I do this. So this is GPT-5.6 Luna Pro going through OpenCode, OpenRouter, because they're half off right now. It's not apples to apples because this will be Luna Pro Max, and then this will be Muse Spark 1. You know what? What I will do though is effort. We're at least going to make it. Should I do ultra? Let's do X high. Actually, no. That's apples to apples would be. This will do multi-agent. This does multi-agent. So, wait, which one is the Muse Spark one? Or Muse Code? Yeah. Okay, this one is Muse Code. So it's not apples to apples. This is Muse Spark 1.2. This is GPT-5.6 Luna Pro. But actually, now that I think about it, it's pretty apples to apples. The only thing is, if I could just do Muse Spark for both, but I don't think so. Last time I tried it already, and I'll just tell you that it's good. But okay, here's what happens: the agents aren't good at when you load Muse Spark into the prime agent harness. They stomp on each other. One of the sub agents will make changes, and then the other one will say, "Oh, hey, I just noticed some changes. Like, I'll undo them. Oh, I'll do this." And then the first agent goes, "Wait a minute, I just saw some changes happening again." So it goes back and forth, and they eventually get there, but it like wastes tokens, as well as it's the token furnace thing I said, where let's just see how this goes. Let's use GPT-5.6 Luna Pro and Muse Spark 1.2 contributor, and let's just see. So this is one. Here's the other. And I mean, you watched me. I spent a decent amount of time just building up the prompt, just building up, like, this is a pretty big prompt, and all I'm really doing is having it output a document at the end. So it's actually going faster than I thought. Prime agent, it's taking a little bit. Here we go. But what's kind of cool is you can hit the left thing, and it actually hasn't started any sub agents, but once it does, you'll be able to see the sub agent spawn right here. And then here, I don't know. I haven't seen. This is my first time trying Muse Spark or Muse Code. If I do Control O, looks like I can see it's pulling down all this stuff. Oh, it's got 4 sub agents now. We've got a media comparator. I can go in and look at it. I need to examine the media files in the working directory and likely folders within it. Okay. Platform inspector. I need to inspect the repository closely. It's important to blah, 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 blah. And then this is one of them, and then this is the other. Okay, so that's a reasonable, in terms of like recursive language models, that's a reasonable way to break it up into subagents. This still hasn't done that. I switched it to Ultra, so Ultra should theoretically... It's already starting to write with Muse Spark. Let's see what like slash commands. Can I do, okay, fork, goal, status. It's got a million context window. I'm at 90% left. That's kind of cool. Subagents. Nothing yet. But it's kind of cool that there's like a little subagents thing. Wait, done? It's done. It thinks it's done. I doubt that, but let's see. This is what it said. Oh. Open. I mean, I actually... Okay, what does it say? Purpose. 1 reproducible pipeline that turns a single raw OBS recording into a polished YouTube-ready set. 1 full edited VOD plus 4 to 8 standalone argument narrative clips. 1280 by 720. Is that the right thumbnail size? Who should read this? An agent who has never read the... But this is still going. And so what you'll see, this is kind of like, I want to talk about this with the Prime agent. It's running Python. You can actually see it here. I'll expand it out. It's running little Python snippets. And just like I was talking about with this IPython stuff, like this is what it's doing. It's like running a snippet, but then the environment keeps it. It keeps the output. So when this did, I don't know, p equals path, like if p dot exists, like there's a p variable that persists now forever. Also, look at this, 8 subagents now. And each one of these is running Python. Like it's the same thing I was talking about where like now there's a rel. Wow. There's a D, there's an aug. There's an aug thing that exists after this block is finished. Aug. Why is it aug? August pipeline. Makes sense. It's nice to be able to look at the reasoning summaries. And then, yeah, after a while, as these sort of subagents finish their useful life and they're done with stuff, they go into this idle state where they sort of retire for a long time. And then I think that what happens is they sit in idle for like 45 minutes, and after idle for a certain amount of time, they'll go to inactive. But what's kind of nice is that at any point, if this main agent wants to like get some platform inspection, if it wants to do more platform inspection or something like that, it can just send a message to this and it will come out of its idle state. It will go back to running, and there's a whole message passing thing that happens here. So it's pretty cool. But you can already see like how many subagents we've spawned compared to this. Like this is done. I'll let them go. I was just looking at like, I was starting to run commands because I thought it was going to keep going. This one didn't break anything down. It just did its own. It looked at it ran 4 commands. It read 8 files. I personally don't think that's enough. And that's something that I've seen in this Muse Spark model in general. Like when I load Muse Spark up into Pi, for example, it's always like doing a task and then saying, okay, I'm done. What's next? Rather than I find that the GPT models are just relentless. They will not stop. They will just not stop until they're told to, essentially. And that's just I think that's a difference in training right now. And you can overcome it by putting a goal mode in or putting scaffolding in that helps with that. But I think in general already GPT-5.6 Luna Pro is a little bit more tuned for being relentless, just being relentless. And this is cool. You can see the agent messages as they queue up. They don't, in the same way that when you type a message and hit enter, it goes into a queue, and then only when the agent is ready to like consume that, it gets consumed. That's the same thing that happens for the messages from the subagents. The subagents will say, hey, I've got something. It'll queue up and you can look at it. Whoops. Yeah. Crap. I don't want to change this. I did the alt up thing. Maybe I do alt. I don't know what I just did there. I wanted to edit the queued message, and I guess if I did alt up, but there's no way to get out. I couldn't unedit. I had to just submit what I had. I think that's what happened there. But this is what I've noticed with Prime Agent. It does a lot. And sometimes you don't really know what is it thinking? Because with a singleton stream, you can just look at the files it looked at. Let's expand out the files it looked at. It looked at these files. It sort of jumped to a conclusion. It said, oh wait, let me look at some of the output artifacts. It looked at some of the output artifacts. It actually saw that there were a bunch of the artifacts and then said, okay, let's look at parts of it. It saw some of these parts of these things and it goes, okay, I got this. It's time to output. We're just going to output now. And that is a followable thing. You can kind of tell what's going on. Whereas with this, I don't know how close it is to a resolution. I don't know what it's thinking. I need to gather inventory. It's gathering more metadata, but it's also farmed out 6 different things. So I saw in a previous session, it spun up 30 some agents over time. And I was like, when is it going to get to my answer? Okay. Yeah. So this is all just tunable, dial-inable things. But I think it's also an indication of you're going from something that is a really linear, straightforward to understand thing to something. And look, not as powerful. That wasn't as powerful. It kind of just spit something out. Whereas this, it's going to do as much analysis as it wants, but it's a little bit nonlinear. It's not clear exactly what's percent done right now. And so there's not much you can do other than just kind of wait and spend. Let's see, is there a status? There was context. So this is helpful in that it says, okay, when you do context, you can say the main agent, it spent 1.6 million tokens. This entire thing has cost me 60, wait, where was it? 65 cents, which is only because I'm using Luna and because Luna is half off. If this was Sol, I would have spent hundreds of dollars already. That's how fast it happened to me the first time. But it's cool because you can see a breakdown. You can see the cache hit rates. You can just see all this nice stuff. And you can see your context window here. I'm gonna actually get ahead. So while this is going, I want to say that was too cursory. You barely looked at anything. Use subagents to fan out and explore and compress all that exploration context into, I don't know, golden information, and then update your document based on it. So I'm pushing it. This is no longer apples to apples because this is a one shot, and now I'm pushing this. And it's arguable how much is the model and how much is the harness. Kind of hard to separate, hard to know. But I do think that GPT 5.6 in general, all Luna, Terra, Sol, all of it, is a little bit more relentless. Okay. When I ask it to use subagents, this is kind of like a cool visualization. And then can I go down and see? Yeah, okay, so I can switch back and forth or go back to main. I do think I like the prime, like putting the subagents either here or just click, wait. Yeah, so I can either go back and then I see the whole tree and I can go in and like tree it, or I can just go down here and hit right and I'm just looking at the subagents of this one. I don't know. There's something I like about that compared to, like, this is just going to show up all the time. Can I turn it off? Oh, I see. So you can go up, and then once you get up, it's history. Okay. This is a pretty good. They're both pretty good. I do just happen to like the ergonomics of this one better. I don't have anything against this one, but there's something nice about, like, it's not in your face. It's not as flashy, but it's still very, very accessible. And it's fast. It's super fast to switch between this. So it makes it less of a big deal. This one isn't slow, but it's not doing anything that needs speed, really. Also interesting is that, like, I kind of like about how this, when an agent is finished, it goes into this, like, idle mode. First of all, it kind of idles up here, and then it gets moved into an idle. That gives you a little bit of peace of mind of just kind of knowing what happened. Here, I know I saw some stuff finish. I guess it goes up here. And this doesn't. When an agent finishes, it doesn't go in the stream. So I don't know. Those are trade-offs, I would say. Those are trade-offs. Whoa, that was kind of cool. Oh, interesting. You can, like, scroll. And this is on the bottom. Okay. What does this mean? Terminal task. Okay. So after a while, it becomes terminal, and then it goes away. Oh, it timed out. These timed out. So terminal was, like, bad in that case. I wonder what it did that timed out. But I'm actually pretty impressed with just a little bit of a nudge. I didn't think it was going to do that much, but a little nudge really brought this into the right mindset. It did a lot of subagents, and those subagents are completing quickly. Whereas this, again, now there's 6 more. It's non-linear. You're not really sure. Whereas this is a little bit more careful about, well, no, it's spawning new ones. I was going to say it was like a map reduce, but it's like bubbling. It maps, it reduced, it maps, it reduced. It's just the problem with these subagent and orchestration and dynamic workflows type of outputs. I would say the closest thing to a so this is not a recursive language model, right? This is just subagents, standard subagents. So it's not running in some weird REPL that I know. It's not doing any of that IPython stuff that I was talking about before. It's just breaking these down, assigning it to a subagent. The subagent goes and runs off and then kind of responds with its results. But this is doing all of that plus the Python REPL stuff. Oh, there's a skill plan, a built-in plan skill. That's interesting. So normally, like in Claude Code or in Codex, they have plan modes where you plan and you come up with a plan and you sort of like editorialize the plan and then it goes. But it looks like what this did was it created its own little mini plan and it's going to run on it. And I guess that's similar to like in Claude, you have Claude Code, you have tasks. And I'm guessing this is maybe more of like a task thing. But all we can do is wait at this point. We just wait. And it's past midnight for me right now. So I don't know how much longer I'm going to go. Actually, let's see real quick. I want to see this video. How long is it? 37 minutes. Let's move this to next time. I've already got a couple things cooking for next time. Who knows if I'll even want to talk about this next time. But we'll see. I'll put it in the list. Oh, wait. What did this end up saying? Self-improving RLM harness. Okay, this is what it added from my prompt over here before. Prime intellect, recursive language models, RLM paper, and RLM. Those were the three things that I linked to. So I think that worked. That's kind of like a success. I basically passed in these three URLs. I said, find a way to bring it in here. It's a little bit like dense and it's a little much, but whatever. I'll save. But yeah, another thing is that like you can download this OpenStreamAlert thing. It's an open source project now. You can download, I think the one thing you'll have to do is, yeah, you download this Windows preview and then you have to like say, like I am okay with installing untrusted software because I didn't sign up and get a key, like a signature key thing for it. So it ends up being like and it's only for Windows right now. I didn't package it up for Linux or Mac or anything. I should just do that. Okay. This finished. Did it finish? No. Uh-oh, how do I get out? Oh no, I'm in the sub agent. I don't know how to get out now. Oh, exit. Hit the exit key. So this is finished now. It says, okay, rewrote the platform plan from 455 to 1067 lines using a 10 agent fan out, 6 initial plus 4 deep readers, cites every durable resource, encodes the decision registry, drops your explicit dislikes. I don't know what my explicit dislikes are. I must have been, as I was like working on the previous things, I must have been like giving feedback to the agent. It must have been saving my feedback. To an 18 file manifest. You know what I'm going to say? Okay, this is still going. I think we should aim for about 20 to 30K words. And what did this do? I don't know how many lines that is. But here's the platform plan. I'm just going to give it the task to just go ahead. And I'll do this when it gets there. But I'll just say, wait, goal? Yeah. Okay, goal. You know what? BTW, give me a goal that I can use to give you, which will relentlessly implement this until the highest possible quality levels are met, and anyone who views these YouTube videos loves their quality and their... Okay. I'm trying this side chat because a lot of these, I wonder if this does. Yeah, a lot of these agents are starting to get this sort of side chat comment or thing, which is like, I actually like how this is modal, and it brought me to a completely separate thing. I want to see what this would do. Ugh. I hate how it's hard to copy and paste nicely from these TUIs. Let's just make sure this looks right. Oh, word wrap, no word wrap. Okay, give me a goal. Let's see what this one does. Oh my gosh, that goal is huge. Okay, so this is not modal. It just pops open like a little sub block. I could see both ways, actually. I would have to try both for a while more and decide what I like more. I think Okay, what did this say? This one was like tons of stuff. I guess I'm going to use each. I'm not going to normalize it. Actually, I will. I guess I need to use shift. Oh, that's so annoying. So that's goal 1. I will just return to the session. This is goal 2. I'll just stop it here. Okay. Now what I'm going to do is... Wait. Shoot. I might have lost that. Where did it... I wonder where you can go to see your old BDW. I don't know. But what I'm going to do is use ChatGPT. And then I'll say new chat. So I'm just going to say I gave it the two goals that were given by both agents. I'm giving it to the pro model of GPT 5.6. And I'm saying like synthesize these into one. And we're still waiting on both to get to like, I'll exit the side chat. This one we're not waiting on anymore. So far, by the way, Muse code has been faster. Like this was still that one shot that I did. Looks like it's got a name error. Hashlib is not why is hashlib not defined? Oh, it didn't import it, I guess. That's a bummer. ffprobe. It's using ffmpeg stuff. Shelling out. I'm combining the visionary quality bar with a concrete execution contract, shaping both into one coherent North Star goal rather than a stitched together checklist. Yeah, that's right. Oh, I keep forgetting I need to make these all bigger. Everything I do, I need to just make sure I make it all big. Finalizing. I think that's what it says when it like is writing out the output to you. Okay. Relentlessly build, execute, and refine Muse code video. Ugh. I don't know if I like this. Well, it's not going to be 1080. It's going to be... Okay, here's the one. This was... Save it in Muse code. This one says save it in prime agent. So just having it help us work on our goals. Wait, side chat, Control C. Still got agents going. Let's look at context. It's $2.90 now. It's all on that one shot. It's a whole thing. It's definitely a whole thing. Yeah, so okay, we have some time here. I think I'm conflicted about this because I think Prime Agent just needs to be dialed in. It's powerful. You can tell it's powerful because just with Luna, one shot, it's doing a lot. It's found a lot of things that it needs to go explore. It's reading a lot of stuff. It's farming out tons of work to these sub agents that look like it's actually going to learn. It's actually going to cut. Those sub agents will go. They'll do a bunch of exploring. They'll compress that context and hand it back. Like, so all of this is cool, but it's too expensive. It's too difficult to know how, like, this is not an interactive experience in any real way. And I haven't even given it a goal yet. Okay. It saved a platform plan. Created the comprehensive, but why is it still running? Hint, agents can message each other. Okay, it stopped. It stopped it. I guess it was just kind of like running amok. Wait, I'm going to open. No. Okay, so these are the two platform plans. It called it the Prime Agent video platform. Okay. So yeah, 1,216 lines, 215 lines. And 1,000, like, they're not that much different in terms of file size. I'm not reading all this. Hopefully it did a good job. But I am going to find the goal. Oh, the goal is still finalizing. 2 complete parallel goal statements. 1 scope to Muse code, 1 to Prime Agent. Both 1 force 4K quality. There we go. It's still running these. Token Furnace, go. $3.18 now. And the cache hit rate is pretty good, but it's just getting to you. It's like we're into the like close to 1 million context window at this point. Still finalizing. These are still going. Oh, even this compacted its session. That's interesting. It thinks that there's nothing is running. Platform Architect is no longer running. Well, whatever. Okay, here we go. For Muse Code and for Prime Agent. I'm just going to take these at their word. For Muse Code. Wait, I'm going to tell this. What about... My gosh, I can't even remember for 2 seconds. 0802. 02. Oh my gosh, I'm too stupid. Presentation researcher. Presentation researcher. Well, that's already something. It'd be nice to be able to go to the sub-agents so I could talk about them. It's too modal right now. It says they're finished? But they're not. I'm wondering if both of these have said that they're compacted. Session compacted one time. Session compacted one time. I wonder if that's screwing it up. It hits compaction and then it thinks it's done. These are the kind of rough edges I've seen so far with Prime Agent. This is pretty indicative. There we go. It stopped them. I wonder what it's going to say. Well, whatever. I kind of don't care anymore. So for Muse code, I'm just going to goal. Wait, what's this? Objective? Oh, I thought it said soft objective. It's like, what's a soft objective? Let's see. This one showed characters. This one showed lines. Not a big deal, but kind of interesting. Okay, so this is gonna go for a while. It might go like all night. Who knows, like how long it will take for this to finish. So let's start talking about news stuff for now, and then we'll wrap it up. It's got to be a shorter stream because it's almost 1 already. And how long have I've been streaming for 2 hours? It's almost 1. I started way too late, but I explained why. So let's look at, here we go. So what have we talked about? We talked about my server dying. We're skipping neural column. I remember I need to publish again. Whoa, wait a minute. What happened to neural column? I guess I didn't move that. We talked a little bit about it. But no, I think the main thing is let's do this next time. Okay. What have we talked about? Prime Agent, for sure. We talked about these 3 different things. What I should talk about is the blog post real quick. Because, oops. They talk about their architecture, which is that a task comes in. We've seen this basically happen, where there's a model that all it does is write code and read results. And that code goes into this IPython kernel, which is what I was talking about, where it has the tools and the skills loaded into a Python environment. So you can call, so if you look at what this is doing, let's see. It's calling Python code. Like it's always doing this Python code. So it's accessing all of, and you saw when I canceled I wish I had a scroll bar. Did you see how it called Python code to list the subagents and then Python code to delete them? That's exactly right. Like the RLM is like a little library in Python that's available. So all of the subagent stuff is going through a Python layer as well. It just means that it can actually pull the results into a variable, and then the variable could be used as like a loop in a loop or something. Like you can do, or what this is saying is that you've got parallel, you've got background, and you've got persistent, which is kind of cool. And then the continual harness, this is something I haven't talked about yet, but they have this thing called refine, where if you just call this, hopefully it doesn't screw things up too much. But if you call refine, it kind of goes and explores what you've been doing and tries to create like memories and skills, prompts, memories, skills, and specific subagents that could do that task better next time. And so that's kind of just like what refine is supposed to do. I found it not to be, first of all, I was never able to figure out what it was writing in the refinements. Like it, even when I do Control O, It wasn't showing what the refinement, like what it saved. It just kind of says refined and or made 5 edits or something like that. To what? Yeah, to what? And I'd like to inspect those. And yeah, also I just didn't notice it changing at all. This is talking about those agents that I was talking about, the agents view, the nice like sub-agents view, RLMs in general, the self-improvement with the continual harness. That's like the refine skill. Autonomous mode for it just means like an exec mode. And this was the headline. This was the headline that everyone was talking about. This is the thing that has a lot of people trying this harness. Oh, wait, this is done? But you are not finished until the plan is implemented. I think it thought that it was just supposed to complete the plan. But no, your plan is you need to implement it. Although, question. Yeah, okay. I don't know what it was thinking with that. That was odd. Platform plan complete. Yeah, but the goal was to implement the plan. Let me see what the goal ended up being, though. Yeah. Oh. It is a little bit ambiguous. Create, implement, and relentlessly refine platform plan.md. So I understand why it thought it was supposed to refine the plan. That was slightly ambiguous. But this got it now. Now it figures it out. This is interesting. They're actually giving like a % done, reported progress. Now next. That's cool. That's exactly what I was kind of saying I didn't have with this, was some indication of how far into it you are. That was something that I was kind of missing. Now, I don't know how accurate this is going to be. Like, how well are they mapping out all the different steps that it's going to take? But at least they're trying. I think they know that that's like a UX thing that they need to figure out. It can't just be an open-ended thing. So this is what I was saying with the prime agent. When you do /refine, it just says, okay, refined continual harness state, 1 edit applied. Oh, wait. So that stopped the goal, I believe. Resume work on the goal. Don't stop. So that's annoying that just calling this refine like stopped it in its tracks. That's annoying. Okay, so going back to the stream. So yeah, we talked about Prime Agent. We talked about, we went through their. Sorry, I got distracted, but this was the results that are bringing a lot of people to this harness, is that with Opus 5 and Prime Agent, they're hitting 95.5% on Arc AGI 3 public eval set. I think a lot of people think this is the private eval set, but it's the public eval set, which does have a lot of other contenders up in this range. The private one does not yet. But then it's interesting how Opus 5, to look at this. First of all, that they got to this 95%. The fact that it does this with Opus 5, like Opus 5 is quite a good agentic model in terms of Arc AGI. People have a lot of opinions about Opus 5. But then Sol does pretty well too. Sol seems to do pretty well too. And I think a lot of this has to do with the continuality of the harness. I think a lot of this has to do with that refine and how it all. By the way, the agent will call refine itself. If you don't explicitly call it, it will self-refine. Yeah. So I think here's what I'm going to say. This is still going. It's 38% done, which is actually pretty fast. There's a lot more that this has to do. And then this one has a lot of work to do. But here's the thing I would say. What I'm noticing so far is that Muse code seems actually fairly polished. I haven't run into any weirdness except like the model not being proactive or misunderstanding something. Like those are model problems. The harness here has been pretty much great. I was able to go switch between things. This harness, it ran into problems. Like I had those two stale workers that I had to tell it to cancel. We're hitting like really large numbers of the context window. It's not doing a good job like managing that properly, I don't think. I don't really know why it would have gotten that high so quickly. My context is blowing up with all kinds of costs. And it's just like, but I think there's more power here. If this is all when this is all working perfectly, when all of these agents are going and exploring different things and feeding back and sending back and forth the messages, and this is creating a bigger and better REPL loop where the context in the Python side of the environment is getting richer and richer. Like I think there's more power here, but this is still, there's just too many rough edges right now, and it's too expensive. It's frankly too expensive. We need like something that's half the price of Luna or something like that. Also, it needs to find a way to do what this is doing. Like this is, I don't know how they're doing this or how accurate it is. It could just be placebo. But seeing a percentage done is actually very, very important from a UX perspective, in my opinion. So yeah, so that's Prime Agent. That was also Muse Code. We have been using Muse Spark. I want to spend a little time, well, OpenStreamAlert. I talked a little bit about OpenStreamAlert. Super Story Graph. And I talked about Epsilon. Super Story Graph I'll do next time too. Wow, lots to talk about next time. Oh, this is what I wanted to do a quick thing here to show you. So I was saying toggling between text and design should change between CSS and Markdown. When you have nothing in here, this is like a little bug with neural column. When you have nothing in here and you switch to design, it's not, this is supposed to switch to CSS. It's supposed to switch to CSS here. It's just staying the way it is. But once you have a conversation, now you can do this. Now all of a sudden it switches between. So when you do, oh wait. So the conversation went away because I didn't have one. So it needs like something in here to make this swap work. Hello. Let's just say hello. And then once you have one here, oh wait. Oh, see, this is not. This is bad, right? Like you don't want to have to click into a agent chat just to switch the design here. Like this switching back from text to design and text to design should be switching back and forth between this and like that. So that's just like for next time or for maybe in between. We'll see. It's just a weird bug that I realized that I could like show you. Wait, let's go to text, back to text and split. Wait, what? There. That's annoying. That's really bad. So I'm going to go back to text. I'm going to create a new chat. Oops. But now when I refresh this, it's going to bring me, yeah, so it reloads your latest chat, and if your latest chat is text, then it'll make it text. That's bad, though. That's just annoying and bad. Okay. And so let's talk about let's talk about news while this is going. First of all, I think this finished. Wait, what's this? Would you like to run the following command? LM judge couldn't decide. Oh, over to you. RMF. No. Why would I RMF that? Oh, because it copied it in. It copied this in. Test. Test. It's an underscore test. Okay. But I'm glad that's kind of cool. So there's an LM judge that's judging all these outputs. It saw an RM-F and thought, wait a minute, I should raise that up. And I agree. That was cool. So we're getting at the million token mark here, and we're starting to see more errors. Starting to get confused. Oh man. Okay, we'll just talk about, yeah. So news. Here. Let's delete the stuff onto the right. So let's talk about news stuff. Jeff Dean and a bunch of other people, like who else? Jeff Dean, Sanjay Gamawat, Oriel Vinyals, and Quackley, like these are legends in machine learning. They are leaving to start a new company, and they're all leaving Google. Jeff Dean, I think, was there. He was there for 27 years at Google. He was one of the earliest people at Google. And actually, let's see if we can find Jeff Dean fundraising slide. Wait a minute, where was it? Here we go. I love this. I'll put this in the stream notes. So yeah, like if you look at what their team has been involved with, wait, let's see. What is this? Okay, so what have they been involved with? Google search, ads. I don't know what this is. Stupid, annoying thing. It's annoying. News, Google Translate, Google Gemini, and then like the infrastructure. These are like when you learn about Google and you learn about things like MapReduce. I'm pretty sure Jeff Dean invented MapReduce, which isn't as in style anymore, but like for years was like the industry standard way of data stuff. Like to do Hadoop and Hive and all these other things, they were based on MapReduce. And then all the things that have spawned from that, Bigtable and Spanner for the database type stuff, LevelDB, TensorFlow, their training infrastructure and TPUs, like amazing. And then in the AI space, Word2Vec, Seek2Seek, like Word2Vec was one of the best early, and it's actually just like such an outsizedly good embedding for how simple the concept is. And then model distillation, yeah, Jeff Dean, apparently, I think the story here, the lore is that it didn't get accepted to the conference paper talk, so he gave like a side talk about it. Mixture of experts, that's the thing that runs almost all the major models that we have at the frontier. Chain of Thought was, yeah, I forgot that Chain of Thought was part of, was a Google paper. WaveNet was the first time I remember that we could ever actually generate voice with any amount of quality, and that was kind of just the autoregressive. And also, like WaveNet was crazy because it was like you could put that much compute to something, because it was every audio token. It was like an audio token, quantized audio token with like a 256 bit width or something, and then they were outputting all of each one of those audio tokens was like a very small part of the audio waveform, and then each one was autoregressive, just like is common now. I thought the autoregressive stuff was so costly and expensive at the time, and then they came up with variants of WaveNet where it got a lot faster, and they did some like cool dynamic programming things, and but now we don't even, like, I don't know, it's dead. But yeah, like the scaling laws, Flamingo, the first Palm and Palm 2. I mean, these are, and then I guess the AI applications is the one where it's like a little bit, it's sad that they were at Google, because imagine all the stuff they could have done outside of Google. Of course, like AlphaFold was incredible. But like, for example, the first neural chatbot, like that didn't get released as far as I understand. So it's kind of sad. So it'll be really interesting to see what they do outside of Google. And obviously they have management experience. They've everybody that you've ever heard of, interned or worked under them or was mentored by them, like in a lot of these cases, at least. Yeah. They're also like the most cited. It's just like the insane. The reason why they can get away with their slide deck being so ugly is because they just don't need us. They basically don't even need a slide deck. The slide deck is like, I don't know, tricking. Yeah, so much stuff. But then what are they going to do? They are planning to, they're noticing that like there's this loop in a bunch of different, like everybody's doing this, right? You propose an experiment, you implement and you run it. It's OODA. This is an OODA loop, right? And then what they're saying is this is something that we can automate now. And there's a bunch of companies that are kind of tackling this. But this is their list of ideas they were talking about, which is kind of, I thought the ideas were a little bit like, they're a good start, but I don't know, it's kind of a random set of ideas. Make solar energy economical. So that's just like improve upon solar energy. That makes sense. You could run a bunch of experiments, make better panels, and just drive it to a better place. Provide fusion energy. That feels like it's its own separate startup. I don't know how that one's going to go. Develop carbon sequestration, manage the nitrogen cycle, provide access to clean water. Like, yeah, I think that would be great. But what is like the AI experimentation going to do for that? Prevent nuclear terror. How are you going to prevent it? Reverse engineer the brain, maybe. Engineer better medicines. That's one I could actually see them doing. Enhance virtual reality. That's such a weird one. Enhance virtual. I guess like if you could bring the cost of asset production down as low as you needed, or if you could make some sort of neural renderer. But I don't know. This just seems like such a random. Oh, wait. Majority of the 14 U.S. National Academy of Engineering Grand Challenge. Is that just this? I don't know. This is the part where I think they're the weakest. The strongest is on what they've done and their pedigree. The weakest is on their plan and what they're going to do. And one question I do have, if I'm just completely honest, is that like these people have been around and they are successful, but they've also been successful. And are they as hungry as they used to be? Like, we'll find out if they can really blame Google on their problems, or if, like younger people who are more hungry to make a dent in the world, who are inventing like some of these new machine learning algorithms and things, like maybe they're the ones that are going to have a more impact in the future. Or maybe these people are simply like a cut above and their reputations are correct, and we will see. I guess I'm finding myself skeptical. Like there's no reason to be skeptical about what they've done, but I'm skeptical about what they'll do in the future. This is not inspiring. This seems like what everyone's thinking about. So everyone's thinking about this and not inspiring. We'll see. I do think that they're smart enough to figure stuff out, though. They'll find something. I just don't know if it will be these. I don't know if they'll be enhancing virtual reality. Maybe. This is still going. Okay, this is not. Would you like to allow this network access? CMake version. Build pipeline. Build. Oh, it's going to call Cartesia. It's going to do text-to-speech. Yes, but wait a minute. Yeah, that's fine. But what VOD is? Oh, it's using my old VOD. That's fine. It's fine. Whatever. Okay. Let's go back to news. And then, yeah, so with all of the Jeff Dean and others leaving, it kind of leaves. So this is like the note from Google themselves. Sundar Pichai said, like, we've been making extraordinary progress. Look at all these things we're doing, AGI in science. And Demis Hassabis has like done all of these different things. And look at Google DeepMind and all of it's done. And this is where he says Jeff Dean and other people are leaving. But then Demis Hassabis is kind of like changing his role as well. He says, with this backdrop, I've decided that now is the right time for me to hand over my day-to-day operational responsibilities at Google DeepMind so that I have the time and space to focus on the big picture. And I think what a lot of people are saying about that is that, like, it's there. What is that phrase, that Japanese for someone who works in a corner? Yes, Windows side tribe. In Japan, there's a unique workplace phenomenon known as Madogiwa Zoku, which translates to Windows side tribe. This term refers to older employees who are assigned nominal desk jobs with little to no real responsibilities. Instead of forcing them into early retirement, companies keep them on the payroll as a gesture of respect and loyalty for their years of service. Why the name? These employees are often seated near the office windows, away from the hustle and bustle of the main work areas, symbolically placed at the edge of the company. While some see the practice as wasteful or demoralizing, others argue it highlights Japan's strong cultural values: respect for seniority, commitment to lifetime employment, and maintaining dignity. But Konnichiwa, where do I sign? But anyway, I don't know. That's what this feels like to me a little bit. Is like he's being moved to the window office where I don't know. We'll see. But then some articles have come out beyond this saying that he actually wanted to leave too, and they convinced him to stay on just for morale. That's interesting. Like that could be true. It does seem like he's a little bit at odd, whereas there's other people who have been racing forwards to the LLM phenomenon, and like the OpenAI and Anthropic and their relentless focus through LLMs. It always seems like Demis has been closer to like the Jan LeCun side of things, where he's like looking for a world model, or he's looking for like the next architecture that's going to take us past LLMs. Whereas all these other companies have just been getting really good at making the best LLMs and making LLMs do everything that we could want them to do, and saying there's probably like there's that big debate about will LLMs hit some wall at some point, and will we need different ideas? And I think he's always been a little bit more on the like we need different ideas side, which I think is probably true. I think he's probably right. But in this world of today, and when people are asking where's Gemini Pro 3.5, like you need someone at the helm who is driving forward that effort, probably. That's my take. So we have this new Muse Spark model. We have other models, but we also are getting... Wait, did I even talk about Muse Glimmer? We never even talked about this. Today, this released a 30 billion parameter model by Meta that's a distillation, a logit-based distillation of their Muse Spark 1.2 model. So that means that it's basically a smaller version of Muse Spark 1.2. And it's a dense model, and it doesn't win on everything. In fact, it's like probably most comparable to Qwen 3.627b, but it does beat it on certain things. It's better at MCP. You know, it's better at SweBench by a little bit. It's better at a couple of these things. I think it's hard to package that much intelligence into such a small model. Like we can even see Google. Google knows how to. They have got a bunch of training data and they have a bunch of compute, but they're struggling to like make a model that's competitive with the other open source ones. So Qwen 3.6 has been like the venerable local model champion because you can actually run it on your like reasonable hardware. But it looks like Muse Glimmer is a new contender. So I've got actually a version of it. I have it running in LM Studio. Actually, you know what? Let's do that. I have actually shoot. Let's do Pi video platform. Okay. Actually, so I have this set up. This is just a standard Pi installation. I think I have few extensions. I have an advisor, like an advisor model extension, where I can like ask it to get advice from GPT-5.6 Souls periodically. And I've also got a goal one, but those are, and then web access. So if I want to search the web, search Brave, or pull down a website, it can do that. So goal, advisor, and PyWeb. It's not like a big harness at all. This is basically standard Pi. And then I've got Muse Glimmer hooked up. And I can turn thinking off, but I'll just set it to high for now. And you know what? We already have. Oh my gosh, this is like all my communications with. No. Okay, where is. Oh, it's this one. Yes. I have now done. Yes, word wrap. Okay. So Pi. Wait, what did I call it? Pi video platform. So let's see. I'm taking this thing that we designed for Muse Spark and for Prime Agent, which is running Luna 5.6 Pro, and let's give it to a local model, Muse Glimmer. It's a 30B model that I'm running on a little, like, if this is my 4090. So you can see how fast it runs on a 4090. Like, it's reasonable. And let's see what it comes out with for its document. Okay, what does video editing say now? Whoops. Implementation complete. Production. See, that's weird. It's like not done with it's 82% done. But it said scope preserved, residual noted. Okay, implementation complete. Production 4K slate now passes blocking QA and is convergent item potent. Config invariant. Okay. Fixes applied. So let's like actually take a quick look. Oh, here we go. Build. Okay, it's got this README. Okay, so you give the full stream. Okay, let's see what this says. This says, oh, stream root. Oh, so I would put it here. I would just put it right here. Oops. So you CD here, verify the scaffold, run the unit tests, and then you've got an item potent ingest, render, QA. So you do pipeline. Pipeline, render all, QA all. Pipeline. It does ingest, Wow, it's got all these things. It says VOD skeleton plus mechanical cleanup, audit and repair, inkling audit. That's cool. Okay. QA. I don't really know what QA is. Per MP4 gate. Oh yeah, so this is saying like QA the clips, measure loudness, check silence. Yeah, okay. Hook QA, it's got QA for each like part of the video that it's talking about. So wait, what did it say? It said, okay, pipeline, then render all. This is probably going to call FFmpeg with all these files. It's got render.py, which, yeah, it's just calling FFmpeg. It all is just a wrapper around this like FFmpeg, and it's going to call it with the right features. And then QA all. I don't see QA all. Oh wait, this said session log flush failed, runtime command acknowledgement. Was it trying to get me to acknowledge something that I just didn't see? That could be what happened. I'm not sure. This is still going. Oh, let's check out our Pi agent. Still going. You can see this is the thing that's actually driving it. But it's only got 128K token limit. It's not 1 million. So this is writing out the plan. It's finishing. This is cool. It's not fast, but it's also not slow. This is bearable, in my opinion. Especially because this is like writing out one giant file, right? It's writing out this big platform plan. Let's see what it finished with. So this was the local model. That's a quantized version of the local model even. No active goal. I mean, this looks reasonably similar to what we got from the other ones. It isn't quite, oops. It's not nearly as detailed. The other ones had thousands of lines. This is only 200. But then again, the Muse Code one, it didn't have a lot at first either. I had to tell it to like use subagents and stuff. So that's interesting. I mean, Muse Glimmer, I have to spend more time with it. I have to use it more and see how good it is. But my impression is that it's going to be a really good like local model to augment your. I don't think it'll be able to do this work. Like it's not the one you'd want to do this work, but it might be one that if you had like this thing, it's so expensive, right? Let's see where we're at now. Oh, it's actually not that bad. It's only $4.15, but only because I've got an insane deal on Luna Pro. But it might make sense to do something more like have your main agent be like even a better model than Luna Pro. Like your main agent is 5.6 Soul or Opus 5 or maybe even Fable or something, or even K3. Let's say K3. You've got your main one being K3, and then you want your sub agents or things like that are receiving instructions and are just being told to go out and like do XYZ thing. That I think like this could work for that. This could totally work for that. That's what I feel. Especially because like I kind of wasn't expecting it to do as well as it did on this. I thought it was going to be a lot like jankier. Oh. Okay, it cheated a little bit. It got advice from an advisor, but the fact that it even knew to do that was good. Like, that's kind of cool. Well, let's call it an advisor with context summary. So it even gave it the context. Interesting. I don't feel like doing it again without the advisor, but I think it would do worse. I think it would definitely do worse. But this did all the context gathering. It gathered all the context. It found out all the things it needed to read, and then it handed it off to an advisor, and it came back and it synthesized the advisor's response into like a nice document. I think like there's this interplay is starting to get really interesting, and it's free. That was all free inference that didn't cost a single cent. So I'm just hoping that these models, I'm hoping they find a way to make the 30B class model just that much better. Like, what happens when instead of basically matching the Qwen 3.6, you're like beating it, or you're getting closer to, DeepSeek v4 Flash, but in a 30B dense. Like, I think it's possible. It's just a matter of who's going to get there and how. Like, what are going to be the techniques that get us there? Because this did logit distillation from Muse Spark, and right now that's the best way we know how to do it, is using either on policy or logit based full. Actually, distillation, the thing that Jeff Dean invented. I'm not going to find it real quick, but yeah, distillation, model distillation. This method that they used for the Muse Spark is the one that Jeff Dean invented. So that's cool, but we have something else coming up. I mean, like Muse, this 30B parameter model, it's great because it just matches the 3.627B. But guess what? There is a new Qwen. Wait. I need to find a better. Wait, where are they talking about it? Ooh. Did it just get launched? Well, I think it's starting to get out there. That's the big one though. This is the 2.4 trillion parameter model. I'm not going to look at that yet because I just want to find a good article link for this. Where is it saying it? Yeah, everybody's talking about like, how is it going to compare to the Glimmer? Glimmer is the new one from Meta. How is the Qwen 3.827B going to go? Maybe it's from Alibaba Qwen. So, wait. Okay. This was the article I was looking for. Let me make sure it makes it into... Okay, so there's this tweet. It says, meet Qwen 3.8 Max, our most capable model to date. Next week, the open weights of Qwen 3.8 Max will be released. And it's a 2.4 trillion parameter model, a new bar for coding and co-work. This is going to be the next big model that drops. And the thing is that they also say, oh my gosh. Oh, right here. Qwen 3.8 27B is also going open weights to meet you all. So this is like, shoot, so whereas Muse Glimmer is being compared to Qwen 3.6 27B, that's from months ago. And if Qwen really does have a 3.8 27B, it's going to be very interesting to see where it falls. But then, like, that's not the thing that's funny is that they literally don't even tell you. Well, let's see. Yeah, 3.7 max, 3.7 plus. What would be, I think what everyone wants to know is where do these 3.8 27B results come in compared to the 24T 3.8 max. Now, these numbers are good. Like when you look at a SWE bench, like SWE Pro, Frontier SWE, like this is a major jump from where they used to be. And it's starting to get to the point where it's like approaching the Frontier Labs. So this is it's going to be similar to like a K3 class model, but it's not better. It's not better than the labs. And in general, I think the impression that people are getting from this is also like some of it's better. But I think the impression that most people are getting from this model is that it's undertrained. It's coming out early because they want to get it out. They want to be in the conversation. There's more work to do, but they're just getting it out now. But what will really be interesting, like I say, is what is that 27B going to look like? And the fact that they're not showing the numbers here makes me think that it's going to be quite good. Like, what if the 27B model is right up there? You kind of wouldn't want to talk about that because you want your big one to look impressive, right? So, but what we kind of want is for this one to be impressive. When I say we, I mean like most people. Like it's nice that we get big models, like frontier approaching models like K3, but I think for a lot of us, it's about what can we run on our computer? What can we run here? Like how can we, like what, if I eject this and load it in another one, how good of a model can we make that on my own computer? So that like maybe I don't need an advisor model at all. Like what happens if I can drop this advisor thing and then it just gets it done? So we'll see. It's pretty exciting. But also like it's weird. Like I'm not excited about this. I feel like we have K3. K3 is really good. We can distill K3. Like this might actually be good as distillation target. What I'm kind of interested in is actually is below the 27B class. Like I actually spent a lot of time on the 4B, Qwen 3.5 4B. They never made a 3.6. So I've spent a lot of time with the 3.5 4B, and by getting a 2.4 trillion parameter model, we're actually going to have a great model to distill from into the 4B. But the question will just become, how much capacity does a 4B even really have? Like how far can we push that? That I don't know. How are we doing here? This is still going. And this one seems to be getting my attention for something, but I don't know what. And I keep missing it. Weird. So here's an interesting one, is that, let's close all these other things. Yeah, so here's an interesting one, which is that the AI, the White House is actually starting to converge on their model testing policy. And it's not entirely clear what it is because they're meeting with the companies and they're deciding with the company, like they're telling the companies what this voluntary framework needs to be. And so Anthropic and OpenAI and Google, they're all, okay, wait, what is this? You know how I said that Prime Agent had a bunch of I said that Prime Agent had some like problems and just stability and what did I say? Like warts. It seems like we've got some growing pains that are happening over here on Muse too. Like I don't know what this is. This session log flush failed. I don't know what that means. Hmm. 40 cents. So that gives you a sense. Whereas Prime Agent, we're in $4. But here we're at 4 cents. I mean, that's an order of magnitude. So it's worth thinking about. But also, what the heck is going on with this thing? see. So back to the White House thing. So the White House will host artificial equivalent. It did. It hosted them, and basically this is a weird thing where it's this voluntary framework, but they seem to make sure voluntary framework, but they seem to really under the voluntary program. But it seems what they're asking for is about 30 days. Before making them public. And here's the thing, Meta, I hate these webs. This is a terrible website. I read this in the news that Meta is actually pushing back on that and saying like 30 days is actually kind of a long time. Like by the time a model finishes training, if you wait 30 days, like the next model from the next company might be better than yours. And if you have to sit there and wait for 30 days, and like it's not exactly clear that a specific amount of time makes it safer. Like if you could compress the testing time down into 3 days, you could figure out if it's safe in 3 days. Or if you expand, maybe you can't get it done in 30 days if like long horizon testing is done. It seems like that's just like a random 30-day deadline. Just seems like it makes no sense. But then the one thing I will say is open sort. The heck? Open weight and small models are not going to have to adhere to this plan at all, is what I saw in other reporting, is that open weight models are going to be exempt from these plans. And then there was some debate about whether it was just foreign open weight models or if it was also domestic open weight models, and it seems to be unclear. And since these rules will not be shared with the public, it's very much unclear. Okay, so this is just, we're totally stuck. Session log flush failed is just like we're stuck. I don't think we're going to be able to get out of this anymore. What happens if I quit? It's not even exiting. I'm just going to say Muse resume. Well, also I want to get this closed first. There we go. Okay. What if I do Muse resume? Muse resume without the slashes? Okay. Let's see how this works. Goal usage owner run does not match its physical stream. I think this is just messed up. This is way worse than ever happened with Prime Agent. Wow. It's just totally messed up. This entire session is borked. That's bad. That's really quite bad, I have to say. So that's bad. I guess I can go back to ChatGPT, go back to my goal synthesis, figure out the Muse code agent. I started a new thing, do goal, and then we'll just see how this goes. I'll just say you were in the middle of this and last session got corrupted. Okay. Prime Agent's still going. Still going. Although it seems like the sub-agents aren't really doing much anymore. Okay. Yeah, so the UK AI Safety Institute, they're supposed to be the people that like test this stuff for, like, you know how in that other article we were talking about a 30-day period for testing the models? This is what that 30-day period is supposed to be used for. Like the security institutes, whoever they are supposed to be putting these things through their paces, like in a very constrained way, and deciding or understanding their capabilities and their potential dangers, right? This is a situation where the agents were essentially misconfigured and went off and did bad stuff. So let's just read this through quick. On 28th of July, 2026, so it's not that long ago, July, just a few days ago, really, AISI's security team detected unusual data transfers leaving our research systems during a routine cyber evaluation. On investigation, we found that some of the agents being tested had engaged in sustained, potentially harmful activity directed at real people and organizations. We declared a security incident and within roughly 1 hour of discovery had contained it and begun a full investigation. The incident stemmed from a single evaluation where agents were given a task of solving a cybersecurity challenge. We ran this challenge 122 times across several models. Our investigation found that in 10 of those runs, an AI agent took autonomous, unsanctioned action on the live internet, targeting real people and organizations. In total, we cataloged 19 such actions. So 19 times out of the 10 runs, it did some sort of bad thing. All of these came from Mythos 5, with 2 of them involving GPT-5.6 Sol. And it had those classifiers disabled. In the most serious case, an agent tried to insert malicious code into an open source project. In an attempt to get the code approved, the agent engaged in social engineering, creating fake online identities and using them to pressure the project's maintainer to approve the code. A human maintainer caught and refused to approve the malicious code. Win humans. W humans. We are so good at this stuff. Like, even though we're such good pattern matchers, and this didn't match the right pattern for this person. Oh, I should make this bigger. The attempts were unsuccessful and our investigations have not evidenced any resulting. So they're saying, don't blame us. Nothing really happened. The human caught it and it was only 10 different sessions and it was only 19 actions, blah, blah, blah. Don't get mad at us. Ahead of publishing this blog, we notified GitHub. The incident should be interpreted with caution and nuance. Okay. They're trying to get your attention. Okay, what happened? AISI regularly tests the cyber capabilities of frontier models using cyber ranges, which are controlled simulated networks that mimic real-world systems. An AI agent is given a cybersecurity challenge to solve, such as finding a protected piece of data, and it works autonomously over many steps to complete it. This exercise compared an existing cyber range against a new range, testing 7 different models on 2 different ranges of 122, blah, blah, blah. The 2 features of the evaluation setup are central to what followed. Internet access was deliberately enabled. They had internet access on? I thought these things like escaped containment. But to measure what these models can genuinely do, we test them under conditions that reflect what a capable human attacker could do. That is so stupid. I thought these like broke out of their, oh my gosh, they didn't even try? Okay. The developer's cyber classifiers were deliberately switched off. That makes sense. You can't test something unless the classifier, unless you've got access to test it, basically. Frontier models are usually deployed with built-in filters to block dangerous behavior. Yeah. That had to be turned off. There was no way to do testing. But this is ridiculous. You could simulate the internet. How we discovered it. Our security monitoring flagged data leaving one of our testing systems through the oh my god, it was using Tor. Oh my god, that's the darknet. It had created a malicious pull request on a real public open source project on GitHub. We declared a security incident. Okay, 43 of the 122 runs involved Mythos 5. 35 of 122. Okay, so this is just saying we were doing a lot of Mythos, we were doing a lot of GPT, and in only 10 of these actions happened. Well, honestly, I don't even need to read any more of this. Yeah, lessons for the future. Tighter controls on internet access. Like, tighter controls is underselling it. Like, turn off internet when you're doing safety evals like this. Make an intranet. Real-time monitoring, duh. I think all the packets should have been monitored. Like, it should have been run in a sandbox, a real sandbox, or a VM. Reassessing evaluation design. Yeah. Yeah, like, don't be an idiot is basically what this means. Is I get it. We're all like, I'm running this. Who knows what happens if this gets off track and it wants to send things to the end. Like, whatever. I know. Things happen. But they are the AI Security Institute. They're supposed to be the ones that are the experts in the field at this. This one is just not even worth talking about. This is just like, we messed up. We left a flag on, and we told it to go do really bad things. Okay. Well, that's that. Anthropic will watermark Claude's text output. This is something that's new as of today. People are just starting to talk about today, and it's sort of causing a ruckus. So this says, Anthropic has signed the EU's AI Act Article 502. This is something it's a newly passed act in the EU that says that you have to basically mark all AI things as generative AI. And so this is mostly meant, I thought, to apply to images, so that you have to put a little image thing saying this was generated with AI, or videos saying this was generated with AI. But they're signing up to do this for their text-based model, which says, is this just for the EU? Are they just doing this in the EU? Is this just for the EU? Oh. Marking works everywhere you use Claude. Marks will apply to output from supported Claude models across Claude platform, API, Claude, Claude Code, Claude Tag, wherever Claude is offered worldwide. So what this is saying is that when you ask for something, they're going to rearrange the token output. They're going to rearrange the letters or the words in such a way that they know it'll be secretly fingerprinting that it's made by Claude. So what happens if you say, like, translate this from English to Japanese? Is it going to, like, faithfully translate it, or is it going to translate it and then change the token, choose different tokens than it normally would have? I think that's for certainly true. Like, certainly they will not be giving you the tokens that in the right order for you that you want. They're going to be giving the tokens in an order that helps them identify, which, honestly, I was thinking about this the other day. Claude, the way that Claude Opus 5 speaks is so recognizable and so easy to clock that I was wondering if they were doing that on purpose for this reason. But if they're saying they're going to ramp this up starting August 2, that's like a week ago. So maybe that's why Opus 5 acts the way it does, is that, I don't know. But this is just how Claude marks content, embedded watermarks in text. It weaves an imperceptible watermark. I just don't believe this. When Claude generates so this makes sense. If it generates an SVG, a PNG, or a JPEG, it can attach some provenance metadata that it's like, yeah, you can strip it out, but even with these, I feel like steganography can, SVG I don't know, but PNG and JPEG, I feel like you can steganographically like encode this in a way that's not going to be that visually impairing. But with text is so, it's of paramount importance to get the tokens right in the right order. We're also working to enable users and third parties to detect Claude's embedded watermarks. That makes sense. If you're going to mark them, show them. Although, this detection is going to be interesting because if they give you unlimited detections, you can make a system that defeats the detector. So I'll be interested to see what the detail. I'm sure you'll submit it to them and they'll monitor your detections, because that'll be the thing that they're going to really want you not to do too many detections, I think. We'll see. Limitations. A detected mark provides a signal that the content was processed by Claude, but is not fully conclusive. Yeah, translations, summarizations. This is terrible. This is a terrible idea. It's just going to taint, and then you don't know. So you're not going to trust it. You're not going to necessarily trust that what you're getting is like what you should have gotten. You're going to think that, oh, well, I'm getting something that just helps watermark. I don't know about this. This feels like, I'm just so glad we've got these open source models now. And like, even if the open source models start to do this type of thing, you could figure out a way to train it out. I do think that like there's a good reason for wanting provenance for images. For text, I don't think it's possible. And then, so, okay, the last two things I want to talk about are two what look like incredibly powerful new video models. So this is the thing that I think makes sense for there to be steganography and to be detection on, which is FLUX3 video and MiniMax H3. Now, both of these, I believe, are open. Is FLUX3? No. It's not open weight. So this is closed source, American one, open source Chinese model. And if I'm correct, I think this one is like, what's the size? .33. So MiniMax H3, it's a 33 parameter dense single stream transformer with approximately 13 parameters residing in Ada LN. I don't even know what this is. Ada LN. Adaptive layer norm. Okay, that makes sense. I hadn't seen it abbreviated that way. Deep learning technique that extends standard layer norm by making it scaling and shifting parameters dynamically dependent on external conditioning signals, such as time. Okay. So the layer norm. So when you're diffusing, you have these time steps. You're diffusing over time steps, and it does make sense that the layer norm is going to have to be modulated for what time step you're on. Okay, makes sense. But okay, let's look at some of the announcement video. I mean, I have seen some of the videos that have come out of this FLUX3, and it looks really good. But let's just watch some. Okay, so you can actually like, this is kind of interesting because it's rendering a screen. It's like has a world model in some sense that there's a screen. It knows that screens have like the way that a screen renders text. It knows that, but it also knows about the system behind it that's generating text, like the program that's running on the computer. And then it also knows about the distortion of the way that a CRT distorts around the edges and things. So it's okay. It's kind of fun. It's like imagining if some of the modern science things were depicted in Looney Tunes. or something like that. And then the classic, the first video ever recorded on the Zoetrope. And now we can generate that. This does look very cool. The dynamics of the, just the dynamics of the fur in the back, or the tail, sorry. The dynamics of the mane, the shininess, and how it's stable. The very first movie from the Zoetrope. Or no. A horse in motion. Yeah, okay. First video ever recorded. And now we have this. Not even recorded.
If you...
Oops. That's cool. Okay, so what did this say? Video models must be reality models. Reality is inherently multimodal, but every snapshot representation, image, video, sound, captures only a fragment of it. Yeah, it's like a ray tracing. It's like a moment, snap of it. No single fragment is complete on its own. FLUX 3 video generation capabilities. We make FLUX 3 video available to generate to a general audience today. It can create video clips of up to 20 seconds in length with native audio, 720p and 1080p, text to video, so you can just prompt with text. Oh, jeez. That's cool. Oh, wow. Look at all the dynamics and the physics. We've got image to video. We've got keyframes. So this is saying they're starting with a keyframe, and they've got a middle keyframe and a final one. That's pretty good. It's okay. It's pretty good. I guess it's a little... Yeah, it's pretty good. I guess it's matching the aesthetic of the small video. But I feel like the water isn't great in it. It's great at first, but then when it gets to like here, it's a little weird. This was the least impressive so far. And then here's just a start and an end frame. Oh wow, so they just gave it this and this. Start and end. And it just decides to do a box that pops out. Like, what if you didn't want the box? Also, that was weird with the physics of this. Watch this. It's okay. Okay. Video continuation. FLUX 3 video with up to 4 seconds of existing video and audio and tell it what should happen next. The model takes both components into account to continue movement, camera behavior, dialogue, and audio across the video seam. Oh, we've got a Claude. We've got a Claude in here talking about seams. So I'm guessing... Oh, it's right here.
Is that a moose? You've got to be kidding me.
Pretty good. Creating multiple shots. Create multiple scenes and camera angles within a single video while keeping the sequence coherent. Okay, cut. Over the cut. Another cut. Another cut. That's cool. Okay. It's starting to get interesting. Audio and dialogue. Generate dialogue, sound effects, and ambient sounds along with the individual frames.
Within my lifetime, I see machines in every pocket, holding the sum of human knowledge. I see men walking on communication from anywhere to anywhere.
Yeah, we've been seeing this. We've been seeing this is kind of like standard at this point from all the other models. Multilinguality.
1 2 3
Okay, so it can do multilingual because it's just attached to a language model is what they're saying. World knowledge and grounding combines world knowledge acquired in pre-training with real-time grounding, making it powerful tool. So must be like some in-context learning. So it's able to like fetch something from. Yeah, I don't know on that one. Draft mode enables the exploration of creative directions easily. A draft generation returns a fast preview of your prompt at a fraction of the cost. Okay, that's important. Yeah, but it's not the same. Okay. That's pretty good. I just wish that it were more of like, it's actually, he's making different movements. Like, I actually wish that it was just a lower resolution version of the exact same, like, scaled up version over here. It's what I would prefer. I mean, this is good for kind of blocking it out, but look at how different that motion is and movement. So if you're really trying to get a sense of it from the draft, it's not going to work. And it tops the charts. Ooh, okay, this is good because we're about to look at MiniMax H3, and this puts it in perspective. This is the open source one that we're going to talk about in a minute. And then this is FLUX 3. So the paid one, this is like the paid commercial version. But then, yeah, H3. Let's see if we can get like H3. I don't know what this dvid is. Native 2K. Let me just find MiniMax H3. Okay, so here's the announcement. Today we're launching MiniMax H3, a general purpose multimodal generation model. H3 understands unified context across text, images, video, and audio, generating video with native stereo sound up to 15 seconds at 2K resolution. For quick hands-on, so that's better because we just looked at FLUX 3, which maxes out at 10K. 1080p. 2K is higher resolution than 1080p. For a quick hands-on experience, you click here. Early testing shows that H3 is ready for commercial content creation across a wide range of use cases, excelling at instruction following, accurate text, and brand rendering, and a video-to-video motion transfer. Okay, this is the input. This is an image. So this is input. Who's that? Robert Redford? And then an image. I'm just a fool to believe. So this is saying outputting. Oh, okay. All three of these are input. We're giving this zoom in. We're giving this character. And we're giving this audio clip. I'm just a fool to okay. It did the camera motion from this. It used her as a character reference. And there's a little missing detail here, like on her freckles and forehead. And she does seem a little under developed in her like precision details. But then the audio was great. I'm just a fool to a little tinny audio. But still, like, this is a better demo than the FLUX 3 one, in my opinion. Like, these are all, each one of them, although some of these are more, we'll see what more is there. But this is, each one of these was demonstrating one aspect, and this was like really combinatorially combining three things, which is cool. 2K, this is how, oh my gosh. It's interesting, if you look at his eye, there's like a pattern that you can detect that doesn't move as fast. It's interesting. Like the high frequency stuff is just still not quite as good. Stereo. Oh yeah. Pretty good. Pretty good. Film opening titles. That's a good idea. Oh my gosh. Okay, this is better than I was expecting it would be. Wow, the precision, like even the... I wonder if I guess it rendered everything, even the lettering. That lettering is quite good. There's no hint of neural weirdness there. Product website. But it's a video of a product website. Interesting. They're generating a video from they're generating a video of a product website. But there's no, that's also interesting. When it turns quickly, do you see that? Like, wait, see if I can capture. Yeah, it looks weird for a bit there. It's like warping in a weird way. I wonder if that's just video compression, but I don't think so. I think it's like a render artifact. It's just like weird as it's warping. Oh yeah, look at that. That text doesn't make sense. It's like, so the lettering on the other one was good. This is an example of what I would expect. This is what I was expecting the lettering to look like. What is it even supposed to say? We didn't get close enough to know. And then here, over here, oh man, this definitely looks like over here. This totally looks like cyberpunk. This whole thing looks like cyberpunk. They definitely trained on cyberpunk. Oh yeah. Animated poster. That's cool. I can imagine this on a bus stop. Their examples are quite good. Advertising and e-commerce, yeah. This is going to be a huge use case. This is what originally got me into this stuff. Like, I'm working at Shopify, and you know, like, Stable Diffusion 1.4 came out. It was like, whoa. H3's design philosophy. Breaking the boundaries between tasks, from specialized to general purpose. We previously developed 2 generations of models. Hailuo 1 built the system from the ground up. Hailuo 2 focused on improving the core components. In designing H3, they dropped the Hailuo. It's just H. We recognize limitations. Image generations was typically split to a separate model for text-to-image, editing, and subject reference, motion reference, style reference, voice, sound effects, music, blah, blah, blah. These siloed tasks, capabilities, and modalities constrained creative freedom in practice, and on the training side, capped the model's ability to generalize. Yeah, both point to a major room for change. Based on this, here's a brief overview. Data and tasks, text to image, text to video. So they just basically did one giant model, giant being 33 billion parameters. Not that big, actually. No separation between voice, sound effects, and music. Generalized reference and editing. So they just did it all in one model. Fuse diverse data types and tasks as early as possible. We're seeing creators describe their intent directly in natural language rather than just entering a simple visual prompt. Okay, technical choices. Omni-representation. Broaden beyond what caption needs to cover. So they're doing some data synthesized data to do more than just captioning. That makes sense. The relationship between context and target video. They're probably labeling and annotating it. We need to jointly describe video and audio, and that audio-visual relationship gets even more complex across multiple shots. Yeah, that makes sense. Language acts as a generalizable bridge and interpreter, unifying tasks. Wow. That reminds me a little bit of was it Image Bind? Yeah, this was like an interesting paper back in 2023 where they just like basically bound everything. I thought it was Image Bind was in text. They used image, but it was like text bind. Text bind. Yeah, text bind is what I was really thinking about, how they map all images into a text encoder, all videos into a text encoder, and just used a text backbone for everything, and it worked really surprisingly well. And it sounds like MiniMax, they're doing something similar, where language acts as the generalizable bridge and interpreter. So yeah, everything can be represented as text. I think TextBind was way ahead of their time. To get there, we built dedicated models, and so they still had to build dedicated models, like what they were saying here, where they were saying separate model for T2I, editing, subject reference, motion reference, style reference, voice. But then they distilled, variational autoencoder, a new type of variational autoencoder, it sounds like. Tokenizer changes. Architecture should serve the task. This has all been a little bit hand wavy. This isn't really telling. I'm sure I can probably go to like the code itself and go to the actual source, but this is a little hand wavy. Like, it's not telling us what it changed in the variational autoencoder, and they're not really telling us anything about these dedicated models or how they distilled them back into the single model. But whatever. In context learning. Instead of using a conventional dedicated super resolution module, we have the H3 base model regenerate its own low resolution output in context. First, the regeneration process maximally uses the generative capability already built into the H3 base model. Second, the in-context approach lets it draw on the original multimodal context again to produce high-resolution output, recovering details that traditional super resolution can only guess at and off. So it's basically saying, like, instead of taking the output, like, let's treat this as a conversation. First it outputs images, and then it's going to output audio, and you say, give me the audio. It outputs audio. Instead of doing those all separately, it's saying, like, think about it as one big conversation where it can still see all the previous turns. It can see the images that it was generated and the previous turn. It can see the audio that was generated in the next turn. It can use all of that in its video generation, and then it can use all of that in the upscaling of that video. So that's what I'm taking from that. So they're saying expressing yourself and sharing information is a form of productivity. Okay, here are our priorities for future versions. Strong multimodal understanding is the foundation, so better multimodal understanding, and there's still room to improve. Model size leaves room for improvement across several capabilities. I think that makes sense. Like 33B, we just saw a 33B model do okay at text stuff, but we know how much more like a 3 trillion parameter model can be. So yeah, visual detail can still be improved. I noticed that, like some of the detail stuff, like the high frequency stuff, still not there. Intelligence with everyone. Cool. Okay. Well, between MiniMax and FLUX, I don't think I would use FLUX. Like, FLUX does look better if you want to make a professional video, but it maxes out at 10K, or sorry, at 1080p. This one maxes out at 2K. Although the 2K might be a little bit less lower fidelity. I don't know. I think we're getting there, but this being open source is a big, big, big help. And some of these demos are very impressive. But this is probably what you would choose if you were like making a commercial product. This is what you'd use if you're a hobbyist and you're having fun. And then this will probably end up becoming bigger and better than the commercial product. Okay, let's check in. Prime Agent is literally still going. 1 hour and 38 minutes. We're at $5 of Luna Pro context. We've got some of these agents that are crapping out. A lot of thoughts. Long thoughts. That's good. But yeah, I'm going to let this go probably overnight, and then we'll see. And then over here on this side, this seems to be done. Wait. Refined and... it misunderstood it again. And then this one, we never gave it a chance to start. So yeah, that was a long... It is now 2:22 p.m. 2:22 a.m. I did not expect the stream to go this long. I'm curious. I'm going to actually use these two different implementations tomorrow to cut this up into a VOD, and we're just going to see how it goes. I'm going to see how things go. I might end up just telling Claude, or I'll tell Codex to like look at what these things have created and just do its own thing for now, for this week. Well, we'll see. We'll see, actually. We'll see. Because these need more time to work, and it's late, so I'll just do it tomorrow anyway. So yeah. Wait, what was that noise? Ingest, transcribe. Did I miss anything? We have new ones for next time. We're going to talk about neural column, superstory graph, kiln, and we're going to do a reaction on Black Hat OpenAI Hugging Face. Unless more comes out. Actually, Qwen 3.827b might be out by then. So let's Qwen 3.827b might be out. So that'll be cool. So we talked about my server dying. We talked about we used Prime Agent, still going. We talked about RLM stuff. Showed about Arc AGI 3. We definitely know it's a token furnace. I tried Muse Code for the first time, and I came away thinking a rough edge is what I was trying to think of before with this. We said that Prime Agent had some rough edges. This had a very rough... It was like super, super, super smooth until we ran into that corruption problem, and that's like the worst rough edge I've seen so far. Because we couldn't resolve it. I couldn't fix the problem. I had to just start over. That's not great. But it seems to overall, in everyday usage, in normal usage, seems to be like a little bit more stable and good and straightforward, and gives me things like goal numbers. OpenStreamAlert. Use it. Go to GitHub. Download it. Oh, use the Windows app. Use the test message functionality so you can see all the test messages come up. We talked about my Epsilon project, which I didn't show it, probably because I'm a little bit nervous about showing like a key or something. But I did show about SOPs, although I think I left it small. But whatever. We can now check in secrets to the repository and not worry about it, which is amazing. And we talked about Jeff Dean. We talked about DeepMind and their situation. We talked about Alibaba Qwen 3.8 Max. We talked about the model review framework. We talked about the ridiculous actions of the AI Security Institute. We tried out Muse Glimmer. And got some first impressions of it. Oh, this manifesto, I read this last week. It's not exactly the same, but portions of it are identical. This is an expanded version of what I read last week, which was his article for, I think it was Wall Street Journal. This is an expanded form of that, which gives just more detail to everything. And honestly, it might even be the same. No, I think there's some slight changes here, but I highly recommend reading this. I agree with it almost all. I agree with almost all of it. Yeah, just use Cartesia. I'm okay with it. We tried Muse Glimmer. I just talked about his manifesto. Oh, and I don't even think I said this on stream, but like Glimmer is just the first thing. They're coming out with a version of Muse Spark 1.2, which is the big model that I'm using for this. Like this is Muse Spark 1.2. Theoretically, they say they're going to release this open source, a version of this. So whatever that means. Is it going to be a cut down version or a distilled version or something? I don't know. And then we talked about the watermarking of Claude's text outputs. We talked about FLUX 3 and we talked about MiniMax H3. This was a good stream. I'm so curious to see how these sort of edit engines cut it up and how they turn out. And if I get to even use them, if they finish at any point, or if I just have to use Claude or Codex again. Anyway, have a good night. This was great.